Everybody. So here's a dynamics example that you should try on your own to see if you can solve it. So let's say you're working at a recycling plant, and let's say you have a crate of bottles that kind of falls down this conveyor. So it slides down this ramp and then falls into this bin. And if you know the mass, the angle, this length here, this height, you have to determine how far to put the bin. So, given the mass, the angle, this length, this height, find D, this distance. Okay. So, and then hint, break it into two parts. Solve this part first and figure out this speed right here. What is this? Right, so do this first, just from here. Then, like, look at this. This is a projectile motion problem, right? Like, you're given an initial velocity like this, and then it lands somewhere. Okay, so and then let me go over how you would do it. So you can pause here, try it, and here's the solution. So the first part where it's sliding down the ramp. You can draw the free body diagram of that mass while it's sliding down the ramp. Right, so it just looks like this, with a normal force and weight. And that's it. It's smooth, so there's no friction here. Okay, and then it's moving down the ramp. So I mean, you can pick coordinates like this. That's perfectly fine. But it's moving this way. So I'm going to pick my coordinate in that direction. I'll call it X. And I'll call this Y. Okay, now which of these is the angle is the issue. So one more time with that strategy. This is horizontal. This is vertical. And then if you look at the picture, right, this is the angle between horizontal and the ramp, which is right here. Right, so imagine like dashed line clockwise, clockwise like this. Okay. So that means the angle is here, right? So if I write Newton's second law decomposed in the x direction here, right? The weight is, the x component is opposite the angle, right? So in the x direction, sine, and the x component of this is 0. And then in the y direction, I got n, and in negative, and then the y component is adjacent to the angle. Mass times acceleration. And the way I pick my coordinate, it's moving in the x direction, so there's no motion in y. So I can cross this out. But really all I was after was this acceleration. So I'm going to solve for that acceleration. Well, m cancels here, right? So, okay, so I got the acceleration of that mass as it slides down the ramp, but I wanted to know how fast it's going when it reaches the bottom of the ramp. So now you think, okay, of all the formulas in the world, this is kinematics, this is a constant, so then that means you can use kinematics for constant acceleration, right? And then all the formulas in the world that you know for constant acceleration, you know this one, you know this one, you can combine these two to get this one. And now you look at what is known and what is unknown. So if we know the angle, we know g, we can solve for this. So we know this as a value. So we know this. The displacement is given, L. So we know this is L. We know this. I should have said, let's start at rest here. Start at rest. So that way we can just cross this out. Here. We got this. So that's 0, 2, and then the acceleration was g sine theta times L. I'll just put the L over here. Okay, so we got the speed at the bottom of the ramp. It turns into a kinematics problem, right? We have this initial velocity, which is known. I'll just call this v0, which is known. Right, this is known. And the angle we know because the ramp was kind of this way, right? So that means the angle is right here, theta. Okay, and then we know this height was h, and it's going to land somewhere, some distance d. So now we just pick coordinates. And you can pick coordinates here, here. It doesn't, how about I'll pick coordinates like this. A good choice would also be to pick the origin right here, where it starts. And I'll just make this like x and y. Okay, so the only acceleration now is, while it's flying in the air, gravity this way. All the formulas in the world that you know, right? This is projectile motion. And in this case, x is where it lands, so it lands at point D. It starts here, so x0 is 0, so this is 0, right? What is the x component of this? Cosine, right? So that's going to be v0, which is 2gl sine theta. I'll just write v0, cosine. And then the ax is 0. Okay, in the y direction, y final lands on the ground. So that's actually 0. Initial is starting up here at h, so h. And then what's the y component of this velocity? It's actually negative, right? So negative. And then sine. And then ay is negative g. So negative. Okay, so then I have these two equations. And then what is known and what is unknown. I don't know this. I don't know this. There you go. Two equations, two unknowns. So in this case, you would just solve for t. So you can like solve this for t and plug it in here. Or solve this for t and plug it in there. That's probably what I would do, right? Which ends up being a quadratic. So solve this for t. You have two values. One of them will be physically impossible. You'll know when you get the numbers. I'll call this equation 1, equation 2. Right, and then you'll get your answer. Okay, so give this a try. Let me know if you have questions. I'll see you on the next video.